welcome Patricio.
Thank you. Oh, I'm on. Hi, bonjour. My name is Patricio. It's an honor to be here talking. So thank you, Nicolas, for inviting me. You can hear me okay? Okay. If I stop modulating and it don't make sense, please feel free to stop me and say. And I don't have problem repeating myself. So I came today to speak about shaders as a computational language of light. A language which I love and is one of the most poetic concepts on computer graphics. But at least in the last moment, I decided to change kind of the angle of it. The original talk was a good talk. It was one of those talks that make you look very smart. And it was all about the elusive nature of light and how it has changed the world that we live on. And even the process of learning what is light and how it behaves has changed humanity, right? And I even made these highly biased slides of people who has been transformed by light and had to transform and shape our world. But when I was cropping Saliman, I remember the picture of their kids. She has this very controversial series of pictures of his kid. And I was thinking that rather than being touched by light, she was transformed by parenthood. So, and also I remember William Kentridge talking about the time when he was a stay-at-home dad while his wife was bringing the bacon home. She's a doctor, and William Kentridge spent time with his kids making animations using umbrellas and things in the house. And this is more close to our community, where we have the free universal construction kit from Golan, which was inspired by the frustration of his own kid while he was trying to connect pieces from different construction kits together. So kits change you, especially if you're an artist. And I think you have this window of opportunity to go back to this pretend-like state of mind through the lenses of a brand new person. And I don't know, who here is a parent? Yeah, I know. Thank you. I'm also a parent. I have a 3.5-year-old kid, Lucas, and another one coming for Christmas, Sophia. Thank you. The real hero of today is my wife, that she's staying in California. She's pregnant. She's taking care of the toddler. So a big thank you to her. She's what is actually making this possible. Otherwise, I will be taking care of the kid. So Nicolas recently became part of our group, our select group of parents. And I want to congratulate you. And also that inspired me to change the angle of this talk. And in order to symbolize this new chapter on our lives, I take the liberty to take the name of the talk and change it a little bit and talk about growing and what it means to make art as a parent. And hopefully I'm going to keep talking about shaders, but I want to weave in some of the background on how that actually born at home with interactions that happens at home. So bear with me. If the talk gets weird, it's because I put it together very recently in this dramatic change. I want to start with the book of shaders that Nicolas was mentioning. By the way, that's how we met. He translated to French, and also he wrote a chapter on it on how to make it easy for people to go from JavaScript to shaders. So the origin of this book is in 2015, while my wife was in the last month of pregnancy of Lucas. And I enter in what is called nesting mode. And for those that doesn't have kids, is when you realize that your life is going to change, and you basically freak out. In my case, it was a whole compulsion of creation. So I wrote like the 10 first chapters, and which is, I think, 80% of the book. In those couple of weeks, then my wife published it. She's the editor-in-chief. And so what was my way of coping with anxiety caused by this like uncertainty coming? The book is a gentle step-by-step guide on how to make fragment shaders. And part of the design was based on this idea of reducing the friction between presenting a concept, which in shaders are quite abstract, and jumping into action, allowing the reader to start tweaking and modifying the code as soon as possible. In order to make this transition easy, I had to make some small tools, starting for a sandbox where I can like put the shaders embed the shaders in between the book. Then that led to this editor. The sandbox in itself, the name is GLSL Canvas, while the editor is called GLSL Editor. I'm very creative with names, by the way, and you will notice towards this talk. The editor itself becomes so useful for me that I actually make a standalone version and becomes part of my day-to-day way of like making prototypes and like share snippets of code and like ideas. So GLSL Canvas is the sandbox, GLSL editor is the sandbox plus the editor. One of the concepts, I think is one of the core concepts of the books, is the idea of SDFs. That stands for signed distance field. And here's, I'm going to get a little nerdy. So with SDFs, you can like draw images in 3D and in 2D, but in the book, I concentrate only in 2D. So I'm going to do what you never should do in a talk, which is try to live code something. Don't do this at home. Okay. Especially because my screen is not shared. Okay, so this is going to be extra difficult. Perfect. So here is an SDF of a circle. When I say signed distance field, it means because basically I'm asking, if you read between the lines, in line 2016, I'm asking the distance from each pixel on the screen. So this is our viewport. In the position, we have the glfrag chord, which has actually each pixel received his coordinate. And this is a crash course on shaders. So if somebody has questions, I will take them. So pixel 00 here, pixel 500 by 500 on the top, and then it gets normalized. So it goes from 0 to 1, which is beautiful because colors in shaders goes between 0 and 1, so you can map it. And also there's a lot of beautiful mathematical properties of like mixing and fuzzing with numbers between 0 and 1. But don't get me started with there because this talk will never end. So I will, so we're asking for the distance between each point to the center of the viewport. And that's where you are seeing. And that's where the previous draw was. So I want you to use your imagination and imagine this not as a flat image with a silly gradient, but more as a hole or as a mountain, depending on how you want to see it. Trying to imagine it topographically. You're on top of this mountain. It's kind of like a hill. It's like a rounded hill. And created by the distance of each point from where you are stopped on the center to each point on the screen. That kind of makes sense? Everybody's with me? Yeah, great audience. And this gives you the chance, once you have your distance fields, sun distance fields, you can do a lot of like funny mathematical operations. Like, I'm going to use the step. I made a circle. Thank you. So, I put up a couple of, because I use this editor every day, and for me it's important to have like a good pace when I iterate. I put a couple of like pickers, GUI things, so you can, on the fly, you can change it, or if it's a 2D position, you can change the position also. And if it, for example, if it's a color, if we here put a color, we can change the color of it. Magic. Let's leave it here. I don't want to take the whole time live coding, otherwise I will not get it through. So back to our slides and to SDFs. We actually use SDFs every day. It's in every pocket of you and use it constantly, because font rendering is mostly done by SDFs. And SDFs, in that case, have wonderful properties, which is with the same atlas, you can modify that, the altitude on where you make that cut at different altitudes. Do you remember when I was like changing up and down the step where to make the cut? So you, with the same atlas, if you cut it very top, you have like a light type, and if you go very down, you have a bold. So that's a very efficient way of having like super precise pixel resolution fonts in font rendering, like for example the browser. What I like about this metaphor is that SDFs are pretty much like DOE. It's like very topographical, very physical, if you want the name, and reminds me a lot of like the print press. It's basically, imagine going to a print press, you have a letter, and if you sand it, you have the same letter but bold. And kind of like passionate by these properties of FDFs, I was like thinking how much they are like dough. They are very plastical, so, and you can combine them and cut them and mold them. So back in childhood land, I'm thinking about dough. Also, if you have kids and if you buy a dough kit, it comes with these omnipresent basic shapes. I don't know if you have seen them. So I don't know, the whole childhood, all kids' toys have like the stars, the moons, circles, rectangles. And I start like tinkering in my mind of like, oh, this is a pretty cool way of like introducing to SDFs by using these basic shapes and that you can combine them. If there only can be a way of like introducing kind of like the mold and the dough together. And this, in the process, I don't know how, becomes more dark and obscure, and probably because of the nature of the mystic nature of code, that it looks like spells, and also I started working on this project that I call Pixel Spirit, which is a set of tarot cards that teach you how to do images with SDFs. At the same time, has a inner they have like a progression that introduces new functions and new tricks of how you can combine them. At the same time, I try to be true to the tarot deck. So this is like the shader version of a tarot deck. You can see if you're a tarot lover, I try to be true also in the image that is in the front, which is the render part of the code. to be true to the meaning of the card, the transcendent meaning. Here is the progression that I was talking about. So this is the actual order of the cards, not the order of the tarot, but the order of the cards goes from the void, from nothing. It's like basically a main function with black color. And then I use the step function, which is the one that I just used when I was to basically cut it in the half using the screen space. And then I introduced the idea of like you can use a sine wave to modify that, and then so on and so on. And this is more like the same deck, but through the lenses of what if this can be a library. So each one of these cards hold a different function that is introduced in this progression. The first one is the stroke, is to like draw strokes. The second one is to circle SDF, how to make a circle, which we already covered that. And the second one is more like an operation, it's like to flip. So if you're going to put a stroke and there is already something there, it will flip it between 0 and 1. What was really hard of this project, and I spent most of my time, was in combining all this like complexity and something coherent. So because of this, I had to reconcile so many things. I decided to put the major arcana number on the top. I didn't say something. I forgot something in the process. So the concessions that I made, the compromises that I made is that I only focus on the 22 major arcanas, and then I add some filling cards, which are mostly to allow this progression of the deck that you can read it as an educational textbook, so that goes from nothing to something, right? So so you have in this side that 35 is the number of the card in the book, in the tarot, in this deck, while the major arcana number that has like a numerological also meaning is preserved in the front together with the compiled code and the image and the name underneath. Then I put in quotes as a comment some cryptic numbers with that are like the dependencies to other cards, because that's the beauty of code. When you make your function, you can like reuse that. So you can start feeling how the nerd joy behind this, right, of making them. Then there is the function introduced, and then is the snippet of code on the main function. Yeah, I think I cover most of it. Let me show you how there's more nerd part of this. This is how actually the card look like. Oh, the comments are hard to read, but I can point it to you. They're very faint. So at the top is the number card, which is the one. If it's a major arcana, it will appear the number there. The title of it, which appears down. Then a bunch of stuff. The includes. So these are the cards that are referencing back. Then I have these two comments to sign that this is the function that is being introduced in this card. And then here, this is what is printed on the card. So then I make this crazy pipeline that then I figure out that I make a couple of mistakes along the way, which grab the text, compose it together in Markdown, then in Pandoc, transform it to LaTeX. From LaTeX goes to PDF to PNG. And then in Image Magic, yes, it's a nightmare. I see some faces that are like, why you do that? Actually, I was trying to compile it again, and the back part is not working because there's a new version of LaTeX. So anyway, I set my own trap. But the secret pleasure of this was like hit make, and the whole the Python grabs this, read through the dependencies, and compose the card on the fly. So this keeps me iterating fast, and also what I use to render the image. So the render image is done by another tool called GLSL Viewer. Did you see the pattern there? GLSL Canvas, GLSL Editor, GLSL Viewer. The difference between the rest is this is run natively. This is right in C++, OpenGL ES, and it can be run through the console. There's can load fragments and vertex shaders. Can also load OBJs and PLYs. It resolves the includes for you. Watch for changes, and something changed, it will reload it, even images. In the Raspberry Pi, it works in Linux and Mac. And in the Raspberry Pi, this has something beautiful there. You can launch it without an X11 environment, so you can run it directly from the console. And another important feature is that it can run also headlessly. So in order to compile the deck, I hit make, and it's sending this task to GLSL Viewer, and GLSL Viewer makes the images. And then the rest of gets together with the rest of the pipeline that involves all this like crazy LaTeX and all that stuff. And in the design of GLSL Viewer also is the ability to communicate back and forth through it in a Linux POSIX fashion using console in and console out. So for me, GLSL Viewer becomes one of those tools, that's like Swiss Army tools, that I can like plug it into anything. It can be part of like a Python project. It can it can work together with Node. Any fun. Anyway, I have a lot of fun with it. So this shares the same name conventions than GLSL Canvas and GLSL Editor. I have here a set. Oh yeah, you don't see the. So here is the cards, and here's all the cards, and the GLSL Viewer gets. Like, you get the idea, right? Back to the presentation. Outcomes. Well, this is my kid playing with the cards. He was the first beta tester of them. So the kind of like the seed, the end point of this project became the seed of the next one, and the next one was this idea of actually having my own library. I really enjoy having this like set of like includes that I can add, and so I started like working on a I call it GLSL Library because you know me, I'm very creative with names. And I have, in my work, I have the chance to work on it and extend it. And because I do most of my work also in mobile, and if you have worked with shaders on mobile, there's a lot of things that can go wrong, and you need to be very smart around efficiency. So I was like, I will love to have this library to not just compile it and having the documentation, which is part of it, but also to benchmarking. So, in the comments on the top of each functions, I add some sort of like tests and documentation. The documentation will become, then it becomes a website, and the test, I use Machete for my for my test is kind of, you know, it doesn't have a perfect skin, so you can test your blurs in trying to solve Machete's skin imperfections. Also, it goes away from different biases. And these tests also, I can benchmark how they are performing, and for that, I want to talk to my second favorite thing on the world, which are Raspberry Pis. And so here is where the GLSL Viewer and Raspberry Pis becomes best friends to basically science do some like computer science on it. So here you will see the same library, but being run in a Raspberry Pi 0. This is a $5 computer with a super crappy GPU. So basically, whatever, if it runs there, it runs everywhere, and it gives you good like measurements because, as I was saying before, it can be launched directly from the console. There is no X11, so the GPU is dedicated to you. You can, and because it's a fairly light version of distribution of Linux, there's not other programs running, so you have like pretty much dedicated, and that gives you pretty stable readings. So I think you will see. The second thing that came from that project is that GLSL Viewer started growing. I keep using it today. Now I'm working in VR and AR, so I have new needs from this tool. I need to apply. I use it to iterate on PVR models. So I added like the ability to read any kind of like cube map, hard control on lights, on camera, pre-calculate the spherical harmonics of a cube map. Shadow maps, etc. I also spent some time to add in a debug mode. That looks cool. And another feature that I add is the ability to add post-processing and different buffers. The way that I approach it, because I like to have everything in one single code that I can like easily pack and share. I'm using defines, so you can see here that in this depth of field, I'm doing the blur in these two buffers that I basically like use two flags for that. So this same code gets reused for the buffer number 1, then buffer number 2, and then gets combined in the post-processing. And this is the material shader that is running. So I found this like overcomplicated way of like putting all together in one single shader that I can like easily work, iterate, and then share. I also add some recording. I'm making image. So I have been putting some love on this tool, and it's another little child. Going back to childhood, if the good night ritual is quite sacred, and it's very important. It's a very crucial moment. So we started reading this book to Lucas. It's called Good Night Moon. Obviously the moon is central to it, but it all happens in a room, and the moon is in the back. And if you pay attention, the moon goes up. You can see it goes up towards you go through the pages. And I really like that temporality on that book has like that subtle temporality embedded on it. And we usually close it, and Lucas started asking for words. I want to say bye to the moon that's supposed to be in my screen. And when we were reading this book to Lucas, we were living in Brooklyn. And if you live in a city, it's kind of hard to find the moon, or like the moon like perfectly aligns with your window. So I decided to make one moon for him, and that's how like Luna born. Basically it's one single fragment shader. It's the same fragment shader that is in the book of shaders, but I add the ability to like be always exactly the same, be perfectly in phase with the moon calendar. So it's like a subtle moon calendar that changed also the background color changed. It goes dark when it's night, and it's perfectly in sync with the color of the sky. Also runs in a Raspberry Pi Zero because I have my own obsessions. So for this case, it's a recycled LSD monitor with a Raspberry Pi and some good that is working as a frame. And then I released kind of like a more official and shareable work in using Frame platform. And this was kind of the start of me getting more into astronomy. Once you like realize that through code you also can like predict when the sky becomes perfectly black or the moon is in a specific thing, you get this this pleasure of like, oh, this is all equations. There are quaternions. I know quaternions. So I started like iterating and in these kind of like exercises, teaching myself astronomy. When you start like doing some learning a little bit about astronomy, the first thing that hits you is the issue with scale. Our scale of perception is so limited. The frequency that we move on is so tuned to how we perceive that when you get out of scale, you have to do some tricks in order to like visualize it and to make sense of it. So in some way, these experiences on space also became experiences about time and frequencies. There's also super interesting correlations between time coordinate systems and space coordinate systems. This one was, I was a little homesick. So I wanted to see how the sky changed in a specific moment in different parts of the world. And I live in the opposite hemisphere where I born, so sometimes I get some, you know, want to see back a sky that I can recognize. That this series of experiments becomes this other project called Orbitas, which is more like a data visualization of the orbits of the different planets on the solar system, and also the orbits of satellites, not just the moon, but like artificial satellites. If you are into like connecting with satellites, there's a lot of things happening in the radio amateur sphere around that. That's another talk. And more recently, I have been working for this for way longer, but it is the last one that I released. I have been working on this more is because it's more like a data visualization problem. It's like I used to work on maps, and it's very similar problems that you face when you have maps because there's so much information there that you need to like sort it out depending on what zoom level you are. You're probably searching for different things. So in order to make this work compelling and always interesting, you need to add something else than just like displaying stars by like a camera movement and like putting some hidden things here and there to keep your attention. And for this whole set of exploration, I was using open frameworks. So I more recently add to this family of tools an add-on called OFX shaders, so I break the GLSL stuff that use the same name conventions and the rest, and it works in the same way. So this is kind of like my own set of tools that I use for working with shaders, and I enjoy that I can like bring them back and forth between the web and more things more closer to the hardware. So shaders is a computational language. Language is not only organize thinking, but allows it. And part of becoming fluent with a medium is the ability to master it and to think through it, and also to extend it. Construction tools, and by that, constructing tools are around that. This also gives the ability to start conversations, and at least I try to like show a little bit how one project has been like leading to another one. And I think when you start these conversations, and then you start conversations with other people from your community, which that's why we are gathered here, you also have the chance to start like finding your own voice. And this is more about what I'm working on now. I'm like, I have been very inspired by the work of Matt and Inconvergent, and also the Mercier. Everybody's using the Axidroid. And so I got one, and I have been starting like to port all these experiments kind of into paper, and this has like done great things with my collaborations with my son. So his version is obviously better than mine. But this got me thinking on kind of like medieval sky charts, and how they're like all populated with like seraphims and animals around them. So I got excited like when I saw that, and it's like I'm going to do the same. I'm going to put things around it. And so I have been iterating on this. And one of the nice things that I found with the Axidroid, with this plotter, is that it gets me out of my computer. I have all these like wonderful things that I'm doing, and this whole life of work that is like trapped into this like aluminum box, very nicely, precisely done, but it's kind of trapped there, and this puts works around my house. So they become part of my daily life, and also they are like susceptible to interventions. More recently, I have been kind of like going back to the things that I learned in printmaking class, and trying with different mediums. In a lot of ways, I feel that printmaking is kind of like the ancestor of the things that we do. They have the same problems. They have to deal with computers and with machines, and find their own voice through it. And sometimes machines doesn't like cooperate, but like propose something different, and you're in this relationship, artistic relationship and collaboration with a machine. That's my kid. We're doing stamps, and yes, sometimes a pattern emerged from it. This is more recently. I'm trying some edging. Since I live in California, I have been learning more about the arts and craft movement. And one of the beautiful things about it is that they propose these like artmen and artists are pairs, and it's like a dialogue between them. So I'm learning new crafts, trying new materials. This is also the same edging technique, but I kind of reverse it. It's painted, and then with a scraper, kind of like, and this allows me to go more precise. So this is where this talk ends. It's pretty much open-ended because it's a fluid thing. It's a process, and I'm very excited and honored to be here and to start having conversations together and grow together professionally, be pairs in this trip. So thank you so much.